I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video where we are examining a bunch of compounds and naming them. They are all alkenes, where you have a carbon-carbon double bond. An alkene. That's what we're naming. And how would you name this compound over here? You have a cyclopentane with a double bond and a bromine. You always want to remember this. When you are looking at a carbon-carbon double bond and alkene, they have to be numbered with the lowest possible digits. So you're not going to say that this is 1 and then this is 2, because then this right here is going to get a large number. You'll start here with 1, 2, and then you'll go 3 in this direction. So when you're looking at this, you have here a bromine on carbon 3, so you will be calling it 3-bromo. Because it's a cyclopentane and there's a ene, a alkene, you'll say 3-bromo cyclopentene. That E and E or here will indicate that it's a alkene versus A and E, a pentane. So 3-bromo, and you can hyphenate it, 3-bromo cyclopentene would be a correct name, and it would be just the way you want to name it. So 3-bromo cyclopentene would be a correct name. Let's name this. You have to start by understanding that you have to identify the longest chain which contains the alkene functional group. My longest chain can be what? How about if I were to do this as 1, and also remember the alkene carbons must have the lowest numbers possible. 1, 2, 3, 4, 5, 6, 7. So we're looking here at a heptane because it's a double bond. We'll call it a heptene. I have a 2 and a 3 carbons holding the alkene. I have here a 2-methyl and a 3-methyl attachments to your chain. How about we call it like this? We have over here 2,3-dimethyl, because the methyl groups are attached to carbons number 2 and 3. It takes care of these two items standing off. Then we have over here 2, and we'll say heptene. What does this 2-heptene indicate? Indicates there's a double bond and alkene functionality, but at carbon 2, then it's assumed the next carbon is carbon 3. So your alkene group is between 2 and 3, and this would be correct. 2,3-dimethyl 2-heptene. It will be a correct name. What about this one over here? Now we're paying particular importance to the fact that you have 2 chlorine atoms on the same side of the molecule and being across a certain plane. We're not calling this a plane of symmetry because it's not symmetrical on that, but we're calling it a plane which is bisecting the molecule into an upper and a lower part. You have chlorines on the same side, so we know we're looking at something which is cis versus trans, where the 2 chlorine atoms would be on the opposite sides and you would be looking at a trans. Here you have a trans. The chlorines are on opposite sides of this imaginary plane, so they're trans. Here the chlorines are on the same side, so it's a cis. And then we have 2-carbon compound, which is an ethane, but it's a double bond, so it's an ethene, and it's a cis. We'll say cis, but what is a cis with regards to chlorine? Cis 1,2-dichloroethene. Ethene represents a double bond between carbons 1 and 2 because it's only 2 carbons, and it's coming from an ethane, but it's an ethene because it has a double bond, and 1,2-dichloro, they're cis to each other on the same side, and it would be a correct name. Cis 1,2-dichloroethene. If you were to look at this would be trans 1,2-dichloroethene. Now look over here. This is particularly designed to confuse a student. You're focusing right here on this double bond part, and what is missing over here? I'll show you. I'll redraw everything so we can use this as our working figure. I'm looking here at this carbon. I'm looking at this carbon which is holding an alkene functional group, a double bond. Here you have a hydrogen, here you have a hydrogen. What's my longest chain? Well, I want to always name the carbons with the smallest digits. If this is 1, this is 2, this is 3, this is 4, that's 5, this is 6, this is 7. I'm looking at a heptane, but it's going to be a heptene. But now focus on this fact: the hydrogens are trans to one another. They're not on the same side. These attachments are trans to one another. They're not on the same side, meaning the stems, which are part of your main chain, are also in the opposite configuration. So you have something here which is definitely trans. You have here the carbon holding the double bond as position 3. So we'll say trans 3-heptene, and this would be a perfect name for this molecule, because you know you have a heptane, but it's a heptene because of the double bond, but it's a trans because of the nature of its configuration. Everything is in a trans position with regards to your double bond. The cis and the trans names come about with the orientation of atoms with regards to the double bond carbons that are involved. So keep that in mind. Trans 3-heptene is a perfectly correct name for this compound. This is again another one of those type of configurations where you have to worry about cis and trans. Now look, again identify your longest carbon chain, but give the alkene carbons the lowest numbers. I'm looking at 1, 2, 3, 4, 5, 6. This could be 6, this could be 6. But you're looking here at the orientation of the atoms along the double bonded carbons. I will redraw it for you and it looks something like this. Here you have a hydrogen, here you have a hydrogen. These two hydrogens are cis to one another. You have a hexane, but it's a hexene because of this. So you're looking here at a cis. Don't forget over here, there's an attachment which is a methyl group, CH3 attached to carbon 5. So we're looking over here at cis, and then we'll say this is on carbon number 5 right here. 5 methyl. 1, 2, 3, 4, 5, 6. And we'll say hexene. But we're not done yet because we have to identify the hexene carbon. We'll say 2 hexene. Cis, 5 methyl, 2 hexene. Cis meaning the items around the double bond are in a cis arrangement. The 2 hexene meaning the alkene functionality starts at carbon number 2. 5 methyl, you have this attachment at number 5. That's the correct name for this compound, and it will be exactly how you want to present it on an exam. Let's look over here at this one. You have a cyclohexane ring, you have an ET. What does this ET stand for? It's an abbreviation for ethyl. And what is that? It's a CH2CH3. You're looking here at a CH2CH3, so that's something to remember. You want to notice that there's an alkene functionality. It has to have the lowest number of carbons. Now you can call this 1, you can call this 2, but which one would you want to call it? If you call this 1, 2, then this is 3, then this is 4, and this is 5. You also want to pay attention to the fact that the attachments should have the lowest possible numbers. Here I'm looking at a 5 methyl, but if supposedly I were to number it in the opposite direction, where I'm still going with this with regards to priority 1 and 2 or 1 and 2, but now I have a 3 here and I have a 4 here. I have a methyl which is on a 4 versus methyl in the other direction on a 5, and this is the numbering scheme you want to use. This is correct. So now let's name this based on what I've mentioned to you all. You have the best arrangement in this way. You're gonna say here you have 1 ethyl. The ethyl group CH2CH3 is on carbon 1. You have over here 2,4-dimethyl because the methyl groups are attached to carbons 2 and 4. How will we call this in terms of the alkene and the cyclohexane? We'll say cyclohexene. Do I have to say I have a 1 cyclohexene to show that the carbon double bond is on 1? No, you don't, because if I'm not putting a number over here, it's assumed it was on 1. 1 ethyl, 2,4-dimethyl cyclohexene. This will be a correct name. This right here will be our last one. Now look over here. You have a competition between a hydroxyl functionality and the alkene. What takes precedence? This will take precedence. So you have to call this number 1. You can go 2, 3, and 4, but then you may not get the lowest numbers. But if you did 1, 2, 3, and 4, this way you're getting the better numbers. So the counterclockwise numbering system is better. 1, 2, 3, 4. Now how do we name it? Because if you're doing 1, 2, 3, 4, your alkene carbons would have been 4 and 5. But now you're going this way, you're having 3 and 4. So this is a better way to name it and number it. And that's how we will do it. You have a cyclohexane, but it's a cyclohexene. And you have an alcohol on carbon 1. You can call this 3 cyclohexene because I have the double bond attached to carbon 3. You don't have to say 3, 4 because it's a double bond between 2 carbons. If it's 3, then the next one must have been automatically 4. 3 cyclohexene, you can say 1 all because the hydroxyl group is on the carbon number 1. And it would be your correct name. You can hyphenate it here too. It would be nothing wrong with doing that. So always remember the alkene functionality carbons are always numbered the lowest. If there are functional groups out there which are of higher precedence, then that rule goes out of the picture, but you're still trying to aim for the lowest possible digits on those carbons that are involved. That's it for this video. Thank you for watching.